Welcome back to this class where we are continuing our thing as the utilization of different elements for their useful purpose in industry. So, we have seen that we are used sodium ion, calcium ion. Similarly, one very important element is our iron. So, iron as metallic state, that means iron 0. So, this can be very useful material for construction to many other things, and the metallurgists basically will be interested to handle this iron as the metal, because we all know that the most important part of this metal for making the steel. So, what other thing is there, because iron has a very good source to us also, because we all know it is in the earth core. So, it is basically present over there in the earth's molten metallic core. So, it can have therefore on the soil or on the earth crust. So, how we get this in our earth crust? So, these are available as our different ores or minerals. So, the most important three are hematite, which is Fe2O3, then magnetite, which is Fe3O4, or goethite. Which is one particular form or phase we call, which is alpha phase of FeOOH, which is a very important material, because in biological world also we require iron, as we all know that iron is the major constituent of our blood. So, we can have the storehouse of this iron also. So, as on the earth crust, similarly in our life also, in the biological world also, iron is getting stored. So, it is a very important material, not only in terms of its metallic form, but it has very useful two oxidation states. One is the 2+ state, another is the 3+ state. That means the ferrous ion and the ferric ion. So, when it is in the oxidized form, that means this thing when they are in the mixed oxidized form, but in most of the cases it can go from it is 0, which is your metal, then the ferrous state and the ferric state. So, this oxidized form is available in different rock materials, such as different igneous rock, we get the corresponding iron. So, starting from our seawater to the different igneous rock, this can be very good starting material for inorganic industry or inorganic chemistry industry. So, for their usefulness basically, that means making this iron. So, we know that very old industries in our country, these are iron and steel industries. Like we all know that IISCO, Indian Iron and Steel Company, then we have the TISCO. So, all these old companies which are talking with or dealing with the iron as well as making steel, because these were the most useful material at that particular point where plastics or the other materials were not of that much use. So, iron and steel industry we can have. So, they are present in iron and steel industry. So, in this particular course we will see that how not only the iron present in this iron and steel industry, because we will not consider all these things, because of their not use of all these materials. Nowadays we are just slowly moving to get some new materials for making some new applications. But this iron and steel industry were useful for construction still. They are being utilized for transportation also, for making railway lines and all, transportation, then for energy such as our system, that means electrochemistry, the electrodes and the materials, then for manufacturing industry, then for packaging. So this utilization of this iron can give us some idea that how the different metallic ions or the free metals can be useful for our purpose in getting these as their bulk constituent for industry. So if we now go from there for the making of different inorganic chemicals, so what are those inorganic chemicals which are very useful for industrial purpose, that we will see, and we will categorize also their personal the percentage utilization or percentage production also. So among the top 50 chemicals what industry can use, so from those chemicals, the inorganic chemicals, basically if we have a list of top 50 chemicals, top 50 chemicals, out of those the 20 will be typically inorganic. In terms of the amount we produce, not only India, by our country, but by some other advanced countries what they are producing. So 20 out of these 50 chemicals which are produced in huge amount are inorganic in nature, and they are basically starting from simple sulfuric acid. So the industry which are making sulfuric acid is very interesting. So we consider them as the bulk chemicals, and how these bulk chemicals will be utilized for making some other compounds, because this can be very useful not only in terms of its acid, that means it is giving H plus, as well as the SO4 2 minus, and this we all know that this we can get from SO3, or we can get from SO2, or initially we get it from elemental sulfur. So if we can huge amount of sulfur source in our hand, that means if we are able to produce sulfur which can be oxidized to sulfur dioxide, and that sulfur dioxide can be oxidized to sulfur trioxide, and this on reaction with water basically in presence of some catalyst giving you sulfuric acid. So making or production of sulfuric acid will give us some idea that we can utilize this for making different salts. So for we are considering that we can have some very important salts of calcium or important salts of sodium, where we can utilize at the corresponding sodium bisulfate or sodium sulfate. So this can be the very good source of sulfate ions. So not only in terms of its inorganic acids form, so this is an inorganic acid, but also is a very good supply, giving very good supply of the corresponding ions as the sulfate, or it can go for making the corresponding sulfonation reaction in organic chemistry. So the organic sulfates can also be produced from these, so that we will see that how these typical inorganic starting material can be useful for different industrial purposes. Then along with sulfuric acid we can have the production of the corresponding ammonia. So these include within these 20 numbers, that means 20 inorganic compounds. Then we can have the nitric acid, where it can have the corresponding property of acid as well as the corresponding nitrates, and this can also be utilized by combination of these two, the corresponding formation of ammonium nitrate, which is useful for different purposes, which can be a good fertilizer. Then we can have a metal ion based very important source of material as pigment, which is titanium dioxide, rutile. We know two forms are available for titanium dioxide, one is ilmenite and another is rutile, but it has tremendous application in the industry. So, from the source of these as the corresponding ores or minerals, we can go for the production of titanium dioxide in industrial scale, and also we have seen that we are able to produce sodium silicate. So, this also comes under this particular number, that means the 20 numbers of a huge amount of inorganic chemical production that we will see. So, we will just now go for the checking all other things, that means how we can utilize this as the corresponding one for making this as the corresponding one for our introduction part. So, we can have the typical industry which is dealing with inorganic products, and I gave you all these examples. What are those corresponding inorganic products which can be utilized for different purposes. So, what are those purposes? Basically, it can increase the wealth or add value. That means we can have some value added products by taking the raw materials such as this salt, what we have seen, the typical sodium chloride salt. So, at one hand we can have the sodium chloride, and on the other hand we can have the typical limestones and the oil. So, this will not cover definitely, because this is will come under the petrochemical industry, and mostly this comes under the polymer industry or the organic chemistry industry, but this will not typically come under your inorganic chemical industry. So, which are then either directly or indirectly can convert the different compounds to some value added products. So, the entire range of chemicals. So, what we can have, the entire range of chemicals, whether it can have a, you can have a corresponding organic chemical or a polymeric chemical that can be converted by some chemical reaction to some other product which we consider that are more sophisticated one compared to your bulk or raw materials. So, what we will see therefore, that these products basically can arguably improve our lives and lifestyles, and without these we could not live the way we do without them. So, basically we can use all these materials which can add some value addition to the products which we use for our day to day purpose, and which can increase our lives and lifestyles. So, this basically we see for the chemical industry part. So, it is also coming under the corresponding part where you can consider this as the manufacturing industry. So, if we are going for manufacturing chemicals, we can consider is as the typical manufacturing industry is not that you are making some mechanical products. So, mechanical engineering products for making this, but these chemicals are also can come under this manufacturing industry, and within this it plays a central part. And even though it is by no means the largest part of manufacturing sector, because the amount in terms of some million tons of this sulfuric acid, the ammonia, the ammonium nitrate and all these, the amount of all these bulk and raw materials are huge in amount. So, that is why they are a typical manufacturing center what we can consider. So, from the mining part, that means from the geological aspects or the geophysical aspects, for mining of these ores and minerals, how we can convert the different chemicals to materials that we can see. So, initially we can have the bulk materials which are obtainable from our ores and minerals and which will be converted to the different materials. So, the materials giving us to form the different types of sophisticated other products is basically obtained for mining, and these are typically the natural products. So, large number of materials which we consider as the numerous materials which can be used for chemical processes or another, or that ultimately are formed into some end user product are mined. That means which are useful, like your hematite or magnetite or rutile or ilmenite will go for mining those materials only which can give rise to some useful final products. So, the numerous materials will be in our hand from the material what we are mining. What is mining then? So, mining can be applicable to all other materials, not only getting these for hematite or magnetite or limestone or gypsum. So, it is a typical term which implies certain processes such as the removal of hilltop, particular source we know if it is not underground one, and creation of a large pit. Through that pit we will be able to dig out the material which will be useful for our purpose, or sometimes digging a deep shaft into the earth to extract some metal or ore. So, typically we can get some metal from that particular pit, or we can get some ore or mineral from which we can utilize the formation of the different inorganic compounds. So, mining will be the integral part of industrial inorganic chemistry, and how we can utilize those stepwise we will see that what is in our hand. So, by doing so, sometime we can utilize the insertion of pipes. So, that include the inserting pipes into the ground and utilization of hot solutions or pressurized liquids or sometimes gases to extract a material from the ground level. So, the typical material we can have, suppose the elemental form of sulfur is present over there, how we can take out that sulfur from the ground level, that is one important thing. But sometimes like the oil industry, the petrochemical industry or the petroleum, how petroleum can be removed if we can have a source of petrol or the liquid like oil at the ground level. So, there will be different techniques for that particular purpose which can be utilized to get those materials in our hand. So, as we have given the example of seawater or the ocean water, where from we get different types of materials which will be useful for our purpose. So, let us go back to that again, that how the mining part or the mining of some important inorganic chemical is possible, or the availability of that particular material will be there from the water, whether you can have a seawater or pond water or ocean water, and their particular utilization, because we have seen in our previous class that a large amount of that particular water is always useful for industrial purpose, particularly for washing, particularly for cooling, and also for making solutions. So, if we consider some typical reaction, whether it are inorganic reactions or organic reactions or polymeric reactions or organometallic reactions, we will see that many reactions must be run in water, because most of these reactions, because there are certain sophisticated reactions which we use for a non-aqueous medium, but most of the reactions we can do in water. But in several other cases, large scale reaction chemistry is basically being utilized by use of water, as one of the reactants. Just now we have seen that how sulfur can give you sulfur dioxide, and that sulfur dioxide can be converted to sulfur trioxide, and utilization of water then to that sulfur trioxide giving us sulfuric acid, the concentrated sulfuric acid, very useful material for industry. So, this particular thing, that means use of water as one of the reactant basically. So, in all these cases we will see that the typical water is there, and that water can be utilized as one of the reactant. So, the quality of water, the purity of water and its particular source is important for utilization of that water for industrial purpose. So, we go back to that example what we have seen in terms of the formula, that means the production of sulfuric acid. How we produce this sulfuric acid is basically as well as of three other large commodity chemicals. So, we have seen that what we can consider as the raw material, we have seen as the bulk material or the bulk inorganic chemicals. Now, we can consider another terminology, we are utilizing it as the commodity chemicals. So, this commodity chemicals like that of our, apart from sulfuric acid, we can have sodium hydroxide, elemental chloride we can have, or elemental chlorine and elemental hydrogen. Is known as the chlor-alkali process are the examples of such processes where we can utilize water. So, the production of elemental chloride or production of elemental hydrogen, because the elemental hydrogen production that immediately tells us that we can get H2, the elemental hydrogen as the hydrogen gas, which is a very useful material nowadays for industrial purpose, we can get it from H2O, that means the water. Similarly, how we can get the elemental chloride, whether we get it from seawater or the ocean water, which is a huge source of chloride ions along with sodium ion as sodium chloride. So, we can get in some other cases the inorganic materials or inorganic compounds or inorganics extracted from organic sources. So, how we can convert it. So, that is a very important thing, that whether we go from inorganic material to organic material, or the organic material can be consumed or utilized for making some useful inorganic compound or material. So, we have seen that if we consider sulfur as a typical organic source, is debatable definitely, we can consider this as inorganic source also. So, large scale production of sulfuric acid, so we need to have a good source of sulfur in our hand. So, we can have the different organic source of sulfur also, that means sulfur bearing organic compounds also can have, the organic sulfur compounds also we can have. From there we can also make the corresponding sulfates or the sulfuric acids. Similarly, one other organic source is the production of carbon black from organic feedstock. So, any organic material, the wood, the other jute material or any other thing which can be burnt away to get it as the corresponding carbon compound or the carbon black. Because all these are organic feedstocks, we all know the mostly they are making or they are forming from carbon, hydrogen, oxygen, nitrogen and sulfur. So, if they are available from simple carbon and hydrogen compound, that means the hydrocarbons we all know like methane, ethane and all other things. So, the hydrocarbon can be burnt away. So, these hydrocarbons can be converted to your typical carbon black. Similarly, the alcohol type of thing where we can have carbon, hydrogen and oxygen, or any other compound where we can have also nitrogen and also we can have sulfur. So, the production of carbon black, because the carbon black has a huge market and we can utilize from making the tires, the road car tires and all other things. This carbon black will be very much useful if we can make them via some simple technique from the organic feedstock. So, this can be considered as typically inorganic, but it requires the organic feedstock. So, again like that of our sulfur, the carbon black only we considered as the inorganic material. So, the industry which is dealing with the carbon black can be considered as the inorganic industrial chemistry for making different quality of those blacks. So, one is the source of air like that of our water. So, what are the different things what we can get? Because in our previous class what we have seen that we can categorize the thing that what are the materials we can get from air, like hydrogen we can get some amount, the oxygen we can get, nitrogen we can get. So, typical air can be a good or starting material for chemical transformations and production of inorganic chemicals. Suppose we get typical dinitrogen, the nitrogen gas, and nitrogen gas has typical example for different reactions. So, if we can convert that nitrogen like sulfur to nitrogen monoxide or nitrogen dioxide to ultimately to nitrates and nitric acids. So, that nitric acid production like that of our sulfuric acid production is also a very useful inorganic chemical for industrial purpose, but that we basically get from air. So, utilization of nitrogen from air is a useful practice or useful technique for getting some value added inorganic chemical like that of your nitric acid. We can also add up hydrogen to this nitrogen to get ammonia or urea or any other fertilizers. So, that also give this, that means nitric acid is formed. So, the liquefaction, so air liquefaction plants basically. So, the liquid air we can have which can give us a vital starting material for processes that make sulfuric acid, because for the oxidation of sulfur we require oxygen, and that oxygen can be utilized for making sulfuric acid. Then ammonia, then nitrogen from air is coming for making ammonia, and the same nitrogen can be utilized for making nitric acid. So, all these cases are useful for getting nitrogen from air and converting that nitrogen to some useful material. So, those useful materials are sulfuric acid to nitric acid. So, along with this O2 and N2, what we are getting? So, getting O2 and N2 from air is a useful thing, and along with that we also get carbon dioxide, because certain amount of air, we all know that certain amount of carbon dioxide is always present in air, and that carbon dioxide can be useful like silicon dioxide. We have seen that the silicon dioxide can be converted to silicates. Similarly, if we are able to convert this carbon dioxide to carbonates, and those carbonates can be separated out as a very good starting material for different carbonate salts like sodium carbonate or bicarbonate salts like sodium bicarbonate. Along with these, that means the source of O2, source of N2 and CO2, we can have the inert gas like argon. So, this argon can also be separated out from liquid nitrogen, because we all know that industrially this liquid nitrogen or liquid oxygen plants are there, and those liquid nitrogen and liquid oxygen plants can also separate out this particular gas as the argon. Also, some amount of helium can also be separated out, because helium is also a very useful material for running different instruments and all other cases. So, it has also very good industrial prospect for making helium in the industry scale. For all these, that we can have the further chemical reactions to follow to utilize these starting materials. So, we can use this as for this. So, air, in air what we can have? We can have the different components, and so far we are considering three. Why we are talking or why we are calling these three only? because the percentage wise these three are the maximum one. So we have nitrogen of 78%, oxygen of 21%, and then we can have argon of 9300 ppm compared to neon, which is 18 ppm only in air. So it is possible to utilize the technique or the industrial process to get argon in the liquid form or the liquefied iron, and then we can have the liquid nitrogen also, and also the neon, not only for the gas purpose, because the storing of all these materials will be useful if we are able to store it in the liquefied form. Then krypton and the xenon. So one, we are getting this from argon to carbon dioxide to xenon, and interestingly what we see that in air the concentration of argon is more than that of our carbon dioxide. So whatever carbon dioxide we can have, we know that due to global warming and the environmental aspects we always consider, and our concern is more for the amount of carbon dioxide in air, but these are all in 400 to 500 ppm level. So this boiling point scale is also giving us some good idea about the corresponding liquefaction possibility, or how quickly we can go for the liquid form, because this particular temperature is very useful, because some organic reactions, some other organometallic reactions, and running the instruments, this 77 K temperature is very useful. So cooling of some instruments like our NMR spectrometer or MRIs and all these things, we can have the magnet, the permanent magnet. So this permanent magnet is always dipped within this liquid nitrogen as well as the liquid helium. So within liquid helium or the liquid nitrogen we can have all these things. So these are useful for making nitrogen in the liquid form or the liquefied form. So we can consider this as our next class will follow from here. So we will follow the primary inorganic materials, the different inorganic materials, how we can consider, because the different inorganic compounds we can have. So not only these gases, but we can also have carbon monoxide, the different carbonates, the cyanides, carbides and thiacyanates. So in our next class what we can consider that how we can utilize not only the sources, the two sources we have so far considered, one is the source of air, another is the source of water, and along with that if we are able to make some useful compounds like carbon monoxide, the different carbonates, the cyanides, the different carbides and thiacyanates, we will see how we can incorporate those useful inorganic species. That means in carbonates we can have CO3 2 minus, in cyanides we have Cn minus, in cyanides we have CnO minus, carbide C2 2 minus, and thiacyanates that NCS minus. So only the inorganic part, that means nitrogen, carbon, sulfur, oxygen and all these things and their combinations will give us some anions or some anionic compounds or some useful anionic compounds. Their sodium salt or the potassium salts can be utilized or we can make for some useful purposes. So that we will see in our next class. Thank you very much.